Good afternoon, everybody. I'm very happy to be talking to the Greek Scientists Network. My name is Phoebe Koundouri, and I'm a professor at the Athens University of Economics and Business and the Technical University of Denmark. Today, I will be focusing on the water, food, energy, and biodiversity nexus, and I will be discussing science-driven ways of transitioning and transforming from the current multi-crisis towards a sustainable water, food, energy, and biodiversity nexus. My main argument will be that if we can't measure the current status quo in a quantifiable way, it will be extremely difficult to manage the water, food, energy, and biodiversity nexus towards a sustainable future, towards a sustainable management of this nexus. We all know that we are in a state of multiple crises: the pandemic, the economic recession, inflationary pressures, the financial crisis that we are facing the last week. And together with that, the climate crisis, the biodiversity collapse, the geopolitical crisis aggravating the energy, food, and population crisis, and all of these increasing the inequality between the global south and the developed world. As the chair of the United Nations Sustainable Development Solution Network Europe, I am very happy that offer explicit measurement of the performance of each and every country of the world against the SDGs. Why? Because the UN Agenda 2030, composed of the 17 Sustainable Development Goals and the 169 targets within these goals, are our blueprint for escaping the current multi-crisis towards sustainability, towards the future that we want. Since 2015, that the agenda was launched together with the Paris Agreement. A few months later, we are publishing a global report that showcases how each country performs against the 17 SDGs and against the implementation of the 160 targets within these SDGs. You know very well that the SDGs more relevant to the water, food, and biodiversity nexus are obviously SDG 2, ending hunger, SDG 6, sustainable access to good quality of water, SDG 7, sustainable and affordable energy, and of course, anything related to biodiversity, both on land, SDG 15, but also on biodiversity, relevant to biodiversity in oceans and seas. And we also know that in our countries, and this workshop is focused on Greece and Cyprus, we have the transposition of the SDGs into a policy framework within the European Green Deal framework. We have the different policies that are supporting the European Green Deal. We have the Green and Digital Recovery and Resilience Facility that was launched in addition to the Green Deal to help us recover from the pandemic. And there we know that the projects that were approved to be funded by the additional 750 billion of the Recovery and Resilience Facility were projects that were green and digital, 37% climate mainstream, and 20% digital. All this has a huge impact on the water, energy, food, and biodiversity nexus. And we also know that in 2021, we have the EU taxonomy making explicit that sustainable related investments will achieve better loan conditions, and also that big companies need to submit a sustainability report in order to show compliance with the sustainability policies of the European Commission. And we also know that the Fit for 55 package of measures includes 13 different legislative proposals for revising the current policy where in Europe, the ETS, the forest and land use policy, the water policy, the climate policy, the energy policy, the biodiversity policy, all touching on the water, food, energy, and biodiversity nexus. And in 2022, we know that because of the geopolitical crisis with Ukraine and Russia, Europe has focused on REPowerEU, focusing on renewable energy and getting away from Russian fossil fuels and rebuilding the interconnectivity of the value chain of companies and nations. So that was destroyed due to COVID. So all of these policies are the framework with which we are dealing with when trying to sustainably manage water, food, energy nexus. We don't only publish a global report, we also publish a more focused report. The one on Europe is very interesting, I guess, to this audience. And again, we see that Northern Europe is achieving better results than Southern Europe. And indeed, Cyprus and Greece are facing increased challenges. And you can see here that the water, food, energy nexus, and biodiversity nexus SDGs are some of the challenging SDGs for Europe, where you see red, and red is the SDG that is relevant to food. Red is the SDG that is relevant to the management of sea and oceans and land use. All of these include water, are big challenges for Europe as a whole. With regards to access to clean water and sanitation, SDG 6, Europe is performing well, and on average is set to reach the goal by 2030, which is indicated by the green arrow next to the relevant SDG. With regards to affordable energy, again, we don't have red, we don't have orange, we have a yellow SDG, meaning that although there are challenges, progress is made, and we also see a yellow arrow showing progress, but not fast enough progress to achieve clean, affordable energy by 2030. We are an alliance of excellence for research and innovation on IFORIA. I lead this alliance of excellence, and most of the including research institutions and innovation accelerators that you can see on this slide. I will not go through them in detail. I will just tell you that we are more than 200 researchers working on more than 100 projects, amounting to $500 million competitive research funding on areas that have to do with climate change mitigation and adaptation, sustainable seas and oceans, sustainable biodiversity nexus transformations, innovation acceleration, education, upskilling and reskilling, and SDGs and EGDs measurement and sustainable finance. I will click only on the food, water, and energy nexus, and I will showcase the different projects that we are working on, each of most of them in millions, and also and other stakeholders that are working for 3 or 4 years in order to produce sustainable land use and water, food, energy, biodiversity nexus. These are just the projects that are relevant to the water, food, energy nexus, but you can easily understand that what we do on climate mitigation and adaptation and sustainable finance is also touching upon issues on sustainable water, food, energy nexus, and of course is the same with regards to our projects on sustainable blue growth. Seas and rivers are interacting ecosystems, so we have many projects on this interaction which are determining crucial parameters for the stability of the nexus that we are focusing today. And of course, innovation is a crucial element. Our research and innovation projects produce solutions, technological, social solutions, financial solutions, and these solutions need to be incubated and accelerated into the market in order to achieve massive deployment of the solutions, in order to have all other stakeholders in an economy and in a society enabled with these solutions. Giving them the capacity to adopt the solutions is a crucial element for achieving the sustainability transformation on time. And the capacity, giving the capacity means that we also upskill, reskill, and educate people, and we have many programs in that particular domain as well. Going back explicitly to the water, food, energy nexus, you can see here that although SDG 2, 6, and 7 are crucial for this nexus, all of these 3 are very connected with the other SDGs, and in general, no SDG can be fully implemented without the other SDGs being implemented. So we have a very holistic, integrated, systemic framework against us that we need to manage in order to move from the current position to where we want to go. And these are the global maps of achieving the SDGs on food, clean energy, and clean water and sanitation. And you can see that we are facing major challenges across the world. It's not only Southern Europe, it's not only Greece and Cyprus. These are the performances of Cyprus and Greece with regards to all the SDGs. You can see that Cyprus is red, which means major big challenges with no progress. With regards to food, it's orange. With regards to energy, and it's looking very bad again with regards to 6, sustainable access to good quality water and sanitation. So although there is progress with regards to many SDGs, we still face quite a few challenges and stagnation with some of the SDGs, and 2 of them are prevalent in the water, food, energy nexus. The situation in Greece is slightly better, but not impressively better. So we have orange, which means significant challenges remain with regards to the implementation of the SDG by 2030. So 2, 6, and 7, in addition to 15 and 16, which are the, in addition to 14 and 15, which are the biodiversity elements of our economies as society are orange, and with regard to for this red. So we have a lot to do. We have a big road we have a big challenge ahead of us, and we need to find explicit science and data-driven pathways for achieving these SDGs. I've selected 3 projects that give some scientific background with regards to ways, to solution pathways for achieving this sustainable transformation of the water food energy nexus. One of our projects is the Smart Water Futures, focusing on designing the next generation of urban drinking water systems, and it has case studies both in Greece and Cyprus. This is a European Research Council project of 10 million. These are the most prestigious scientific projects funded by the European Commission. Why water? Because, as I showed before, we are facing extreme challenges. This is the situation across the world with regards to achieving the goal, and this is the trend with regards to where we will be by 2030. And why urban water systems? Because half of humanity, 3.5 billion people, lives in cities today, and 5 billion people are projected to live in cities by 2030. By 2050, 70% of world population is predicted to live in urban settlements, and rapid urbanization is exerting pressure on fresh water supplies, sewage, the living environment, and public health. And we are 4 PIs. I am working on methodologies for analyzing decision-making under uncertainty and ambiguity, and experimental behavior science, including no-market valuation economics. We also have Professor Barbara Hammer, who is focusing on explainable machine learning to explain changes in the system, urban water systems, and the influence of certain parameters on long-term decision-making. Professor Marios Polikarpou from the University of Cyprus is focusing on methodologies for real-time monitoring and control, for explainable fault diagnosis and real-time risk assessment for both water quantity and quality. And Professor Dragan Savic from Exeter University, UK, and KWR in the Netherlands is focusing on methodologies for water infrastructure planning and management, valuing robustness and flexibility under deep uncertainties. And we have, we talk about part of what we do under this project, because it's impossible to talk about all of the different aspects of the project. This is a 6-year project of 10 million. We are explicitly collaborating with water boards. I will talk to you about our collaboration with the Cyprus Limassol Water Board in order to showcase how basic science can be translated into something useful and usable for a stakeholder. And in consequence, if implemented, if the science-driven solutions are implemented, it can produce welfare for the greater society. And this is how science can benefit the society as a whole. So here we are focusing on understanding consumer behavior under uncertainty and ambiguity, and in the long run. And we are using virtual reality experiments in order to understand how people make choices about quantities and qualities with regards to their consumption of water, estimating their demands, and showcasing how their demand for water is influenced by socioeconomic parameters, by natural parameters, including natural hazards for climate change and biodiversity collapse, and also using all these estimations for forecasting. We are also building scenarios generation and trying to use these scenarios for robust decision-making in water distribution networks, and in deciding how these networks should evolve over time, both in the medium and long run. Especially difficult to do so in the long run because you are not just facing uncertainty, you are facing ambiguity. That is, you don't know the probabilities of the various events that might take place. We also focus on ecosystem service valuation and creating a database for those, especially challenging because ecosystems are crucial for a sustainable water, food, energy nexus, but not explicitly pricing markets. So it's very difficult to derive a price. And unless you have a price, you cannot include them in cost-benefit analysis. The decisions that evolution of the water network. We also work on ESG, environmental, social governance, and SDGs, Sustainable Development Goals, reporting for water utilities, which is again important because 2024 they have a legal requirement based on EU policy framework and transposition of that framework into national laws to submit a sustainability report. And we do all this through the initiation of a Limassol Water Living Lab, which I will explain what it is. The first thing that we are working on is understanding behavioral and behavior of consumers and also decision makers, and integrating economics with neuroscience and environmental values in order to have a solid, robust scientific framework to do that. And we also try to understand consumer demand by making the distinction between demand and consumption, understanding consumer perceptions, estimating on demand, checking against real consumption behavior, and identifying inconsistencies and flexibilities. Let me very quickly introduce to the consumption demand modeling and monitoring for our water distribution networks through the use of the functional model setting. Here we try to uncover repeated shapes in consumption in the water network, uncover seasonality effects, and then use the shape invariant model, which is a very flexible modeling approach in order to be able to identify a mean pattern and use any observation, any sample profile, and describe any sample profile as a deformation of the underlying pattern. Such a model allows us to model the typical daily water consumption profile for a node of the water distribution system. We need at least hourly measurements, and with them we can derive the typical expected profile, employing the notion of future mean combined with the framework of deformation models. And there are certain advantages in this modeling. Typical daily consumption shapes are captured in detail. Uncertainties and oscillations around the typical shape can be described. Econometric models can be built on the shape invariant model parameters, connecting socioeconomic and climate variables to changes in water consumption, and also different types of dependency between the various nodes can be explored, allowing for extreme scenarios generations, and of course development of monitoring, relying on the estimated in-control profiles to detect potential shifts in the water distribution network. You can see the deformation characteristics of monitoring, and also the consumption shifts detection. We also work on ecosystem services economic valuation, and we are building an artificial intelligence-based data platform and estimation tool that allows us to estimate the economic value of produced capital, natural capital, and human capital that engages in water, food, energy, nexus, and biodiversity management. It is important to capture the economic value in monetary terms of all the different forms of capital in order to have a correct decision-making process. And of course, it's easy to capture the value of produced capital. Human capital is challenging, but natural capital, we have developed different methodologies to do that, because as you know, the demand for natural capital, because it is usually open access, is hidden. Natural capital is not traded in markets, and this makes it extremely difficult to derive the total economic value of this. But we do so through different methodologies, and then we collect data from original studies for these different methodologies. We can do this exercise for the whole of Europe, and then we do meta analysis in order to estimate the willingness to pay for the different ecosystem services, both terrestrial, marine, and freshwater, across the different countries of Europe, across the different regions of Europe, and also find the correlation between high performance in the relevant SDG and the willingness to pay for these ecosystem services. And it is important to have evaluation database which allows the practitioners retrieve the correct economic value of different unmarketed services, water, food, energy nexus, and include that is cost-benefit analysis for the management of the nexus. We also getting a Limassol Water Living Lab. We are also doing that as well, and also in the Netherlands and in a few developing countries through this project. Initiating a living lab means that we are following this analytic approach towards systemic change based on the interconnected set of innovations where each influences the other. Here we are talking about innovation, both in the parts of the system and in ways in which they are interconnected. And the idea here is that we map all the system boundaries, spatial, temporal, and conceptual. We set the objectives. We map the system, including stakeholders, issues, and challenges. And then we start the envisioning process, outlining the desired future state or goal. And once we agree on our future vision, we use backcasting casting in order to identify innovation pathways, working backwards from the future vision. At the end of the day, we are able to elaborate the innovation pathways and identify actions, both in terms of technologies to be used, policies to be implemented, and financial solutions. And the living labs are really a very participatory research tool used often in planning in order to design products and in an innovation which brings together a collection of key stakeholders that explore a focal issue. And it's very important to engage all the stakeholders in this co-design of the solution pathways in order to feel ownership, which basically increases the probability that the solution pathways that you build, the data and science-driven solution pathways, are actually implemented by the stakeholders, because they understand that these are partly their own solution pathways, so they support them in implementation, which is the biggest challenge. And then with regards to ESG quantification and acceleration, we have for water utilities a 3-step projects. First, identifying across the value chain of a business, of a water utility, the status quo of the implementation of the SDGs, and then looking in detail into possible transformations, ESG and SDG transformation that can increase the social footprint of the company, can reduce the negative environmental footprint, and at the time increase the financial profitability of the company. Then at the second stage, we measure the company's ESG performance with specific KPIs. We link these ESG KPIs to SDGs. Then we create hybrid matrices that showcase in real time, based on a data platform that is continuously updated, the changes, the transformations that can take place and have a positive effect on the environmental profile, the social profile, and the financial performance of the company. And at the third stage, we build continuous assessment and monitoring devices that can help the company continue this process throughout. And the important point here is that the environmental, social, and governance criteria can be integrated with the Sustainable Development Goals and provide a very detailed mapping of the performance of the company and how it increases with relevant transformations. And the performance, again, here is crucial to say that nobody is asking the companies to become environmentally, socially, and governance aligned and forget their financial profitability. It's a hybrid metrics that take into account financial profitability and ESG, and provides transformation solutions that support all of this. And this is important because it's important to understand the wealth of opportunities that the ESG and SDGs transformation is producing, is offering, and also understand that the companies that are able to invest and adopt innovations faster, renewable, circular economy, nature-based solutions, digitalization, will be the companies that will become the leaders and win the biggest share of the market. Now, let me quickly introduce another 2 projects coming from the developing world, but very, very useful in terms of the tools they design on the management of a sustainable water, food, energy, and biodiversity nexus. Awesome was a premium project under Horizon 2020, a $5 million project looking to develop a decision analytic framework for managing water systems, water ecosystems, and food across sectors scale in the south of the Mediterranean, an alliance of universities across the Mediterranean, looking at exploring effectiveness of alternative smart food production options, including hydroponics, aquaculture, and aquaponics. At the meso level, we've been exploring integration and upscaling of smart food technologies in the river basin management, and at the macro level, we've been generating future population, food, energy, and water scenarios and regional policies to the meso scale. And at the end of the day, we've been combining demographic projections, crop water use modeling, energy scenarios, ecosystem services valuation, and climate scenarios in order to come up with future scenarios. and identifying explicit pathways for technological adoption, social innovation adoption, policy adoption, and financial instruments design that can lead these countries that you see in the map here that are green towards a sustainable water, food, energy nexus. And all these systems have been integrated into a decision support tool that allows improving water efficiency and identify explicitly where one needs to intervene in order to improve water efficiency. And in this particular model, it was about expanding desalination in coastal and remote areas, pumping groundwater sustainably, expanding greenhouse cultivations, e.g. hydroponics, and promoting less consuming and salt-tolerant crops. But in order to get the very detailed and explicit pathways towards sustainability, this very inclusive, integrated, interdisciplinary decision support tool was designed, and it was co-validated and co-designed through stakeholders' living labs once again, integrating both the macro, meso, and micro level. Finally, let me talk to you about the Daphne project. Again, a very big project of 7 million, looking at two very big river basins in order to develop a decision analytic framework to explore the water, food, energy nexus in complex and transboundary water resource systems of fast-growing developing countries. The main aims were to better understand the WEFE nexus, generate and explore alternative management solutions, and contribute to solutions that foster economic, environmental, and social sustainability. Looking at two case studies, the Zambezi River Basin and the Omo River Basin. Very complicated structures here. The Zambezi River Basin includes 8 countries: Zambia, Angola, Zimbabwe, Mozambique, Malawi, Botswana, Tanzania, and Namibia. And there are key challenges there, the trade-offs between energy production, irrigation, the energy and food, and also the competing demands for water from other sectors like mining, tourism, and water, and also the difficulty in transboundary governments, which is done under the Zambezi Basin Water Courses Commission. And also another pressure was population growth and urbanization, which obviously puts a very difficult pressure and increasing pressure on the water, food, and energy nexus. The other river basin that we worked with was the Omo Turkana River Basin. 4 countries: Ethiopia, Kenya, Uganda, Southern Sudan, and 95 of this basin belonging to Ethiopia and Kenya. And the key challenges here, again, the energy production and trade-offs between food production and tourism. Then, of course, the hydropower dams in Ethiopia impacting negatively on flow regime in Kenya, and also the transboundary tensions and territorial conflict with upstream Omo River located in Ethiopia, while Lake Turkana is almost entirely situated in downstream Kenya. And again, we have population and urbanization pressures. Here we've developed a national stakeholder living lab. We've developed a hydrological water, energy, food model, and then we develop a decision support model that brings together the model constraints and the suggested actions, the pathways for the transition to sustainability, bringing together the economic domain and the environmental domain, where the economic domain includes demographic, cultural, social model, and an economic model, whereas the environmental domain includes an environmental policy model and a water governance model. Bringing all these together under different drivers and scenario produces a decision support tool that allows negotiation simulation for the very complicated stakeholders in these two river basins. And this decision support tool is provided on an online stakeholder interaction area and provides multi-perspective visual analysis of the different solution pathways, and it is constantly populated through our geo portal with the relevant data, natural sciences data, engineering data, socioeconomic data. I want to close this presentation, and I know it's kind of too long, with an overreaching problem with regards to mitigating and adapting to climate change. We know that we cannot afford to go beyond the plus 1.5 degrees Celsius compared to the average temperature of the globe during the pre-industrial era. And we know that we are very close to reaching in the next 2 decades this constraint that was decided during the Paris Climate Agreement. For this reason, the United Nations Sustainable Development Solution Network has launched a global climate hub, which I have the honor to chair. And this hub aims, in collaboration with national government and respective SDGS and national hubs, to co-design national and subnational pathways for the transition to a climate neutral and climate resilient world. That is to identify for each country the optimal dynamic mixture of technological pathways, policy pathways, and financial pathways. And to do so, I've gathered 50 different top-ranked scientists to support the 9 different units that are crucial for the development of these pathways. The first focuses on climate data platforms and digital applications for gathering the needed data. The second on atmospheric physics and climatology for supporting the natural sciences of climate change and the representative concentration pathways that are, of course, in discussion with the IPCC pathways. A unit focus on climate and energy modeling, a unit focus on water, food, energy, nexus, and biodiversity modeling, a unit focus on climate and health, then innovation acceleration, then the financial analysis units for the just transition to climate neutrality and climate resilience, a unit that coordinates the transformative participatory living labs in each and every country, and of course a unit on education, training, upskilling, and reskilling, because we do know that unless we give the capacity to all the stakeholders to engage in this very challenging and science-driven transition, no transition is possible. Thank you very much for your patience.